Okay, hi again everybody. Here's the parts that, well, let me start here. This are the parts that I made last night and showed you, and here's what I was talking about for the other half of the connection. This is the angle globe valve. It's one of the PM research globe valves that I made. I did a whole series on YouTube of those, so you can check them out if you like. I think there was like 13 or 14 parts to the series. This connection, it's a 1/16 inch pipe thread that goes into this part. So this is one fitting here. I started with a piece of 3/8 inch hex brass, and I made this side first. I turned it to 5/16 inch diameter. I undercut a small portion here, and I threaded 5/16 inch 40 here. And I'll go ahead and unscrew it if I can do this one-handed. I made a new nut and a new I actually had one of the male fittings left from yesterday. Oh, come on thing. It's so hard to do these things one-handed, but let's see. Maybe if I slip a wrench on, I can show you. Use this as a blocker. There we go. Alright. So we've got the 3/8 inch brass hex nut, which is threaded 5/16 inch 40 inside there, the male fitting. This of course will be silver soldered when I get ready to do it. And this portion is exactly the same as on this one, which of course makes sense since you're using the same copper tube. And this portion is the 5/16 inch pipe thread. And all I did for this is I turned that portion of it to 5/16 inch diameter, and then I and it's about 300 thousandths long, the distance here, 300 thousandths of an inch long, and I set the taper on my lathe, and I cut just under a 2-degree taper for the pipe thread, and I used a threading die in the tailstock to cut the threads. And I tested it a few times. You want to make sure you get, good 5 threads, I think is the magic number to twist in for full engagement, but you'll be able to tell that by trial and error, which is nice when this part is sitting in the lathe, in a collet chuck or in your 3-jaw chuck, and after you've turned and cut the threads, and you can twist your fitting on there and see if it engages properly. So that was tonight's effort. Here's a little drawing I made of it, just in case my description didn't make sense. 5/16 inch 40, about a 40 thousandths undercut. The 5/16 inch portion is about 3/16 of an inch long. The undercut is about 1/8 of an inch long. The hex portion that I left intact for using on the wrench is about 3/16 inch, and then about 300 thousandths worth of taper here. I'd used just under a 2-degree taper, cut the taper first. Of course, I had through drilled it. So the gases can escape and go through from one side to the other. And then I use the tailstock, the die holder, to make the threads. Hope that all makes sense. I'll tell you what, doing lathe work is so much fun, relaxing. If you haven't tried this stuff, I know we picked up a couple new subscribers, some friends of mine that were asking me about this, and I hope this is providing motivational. The main reason I'm doing these whole things, if anybody's a first-time builder of a live steam locomotive with the million or thousands at least of parts that go into them, the lathe work is a fun and interesting and rewarding thing to do. So once again, I'd like to thank Fred for sharing with me the plans and the inspiration and the updates and feedback on my project, and I wish everybody good luck. Thanks, and I'll keep you posted.